it's been about 6 months, maybe longer, since we posted a video. And this is just going to be a quick little update to let you guys know that we are still here, we are still filming, but work has been a lot slower lately, and so we don't have as much video content to put up. We have been working on this Paragon table here, and hopefully you can see down below here that we have used vinyl over a painted yellow background as opposed to a stencil and painting the colors. So the blue and red is vinyl stickers that are stuck on, we cut ourselves. It really pops. It really makes this table look awesome, in our opinion. New play field, new plastics, and there's some new stuff inside too. So let me quickly take you over here and show you the inside, and then I'm going to show you some new inside. We're looking at the electronics that's going to be in this table, and it's different from anything we've ever done before. To start off with, this board, NB2, is a board I believe from France. I'll put a link down below to the website that it came from. But it's an MPU board, a lot like the Altec board, with switches here that let you, so you can see that, switches there that let you set which game you want the board to be programmed to. The big difference is it has a sound card built on. So it has a library of all the sounds for all those games, and it eliminates the need for the sound card down here. When Mike bought this table, it came without a sound card, and he couldn't find a sound card for the machine at the time. So he purchased this board, and we're just going to be trying it out. Preliminary tests say it works just fine. This board is the board that I normally have set up here as a daughter board to the main processor, but I've rewired it so that it's pinned out to the connector that used to go to the lamp driver board that was situated right here. And this was just a prototype to make sure that this would work here. And we have recently had another board built that will fit in here, and I'm going to mount that up in just a few minutes, and I'll bring you back when that board is mounted there, and I'll show you the difference. The main thing is here you got the input cables here and the LEDs going out there, and that's pretty much all there is to it. And just down here you can see that we've gone to a bigger 5-volt power supply, primarily because, and you're not going to be able to see it, but if you look on the back plane, you see all of these LEDs. These are new LED boards that we're having manufactured also, and each one of them has 2 LEDs on it. So we've doubled the number of LEDs in the whole game, and that required more power than our small power supplies would put out, so we now have a big power supply in there. So let me get my new board installed, and then I'll bring you back and show you that. Okay, I have installed the new board, freshly back from JLC PCB, hashtag not sponsored, but we have basically taken the old board, we've made it surface mount, and we had them surface mount the components for us just to cut down on the work a little bit. But the big change is we've added these XT connectors. If anybody's into model cars and stuff like that, you've probably seen these. They're used a lot on batteries for model cars because they handle a lot of current, more than we need actually, but they're dirt cheap because they're a hobbyist connector, so you can buy them really cheaply, and they're gold plated, and they're really good. So what we're going to do is we're going to have this single wire coming from the power supply down here. I haven't rewired it yet, but it's a single wire coming from the power supply up to here, which is going to power this whole board, and then we're going to have 3 distribution points that can feed that 5 volts out to the lights over here and down under the back box and any place else that we need. We really only probably need 2 of those right now, but we put on 3 because there was room on the board. The only other thing that you might notice is that little red jumper up there. If you ever want to plug the USB cable in, it would connect the 5 volts from your laptop to here. And if you didn't have this turned on, that 5 volts would try and power this entire processor. So we don't want that to happen, or at least it would try and power all the lights on the playfield, and we don't want that to happen. So we got that little jumper we can pull off when we put the USB in to keep from connecting the two power supplies together. And other than that, it's the same old board. It is wired for the connector that's coming down from here, the old light driver board connector. And if you want to use a table that had the two light driver boards, you do have to move a wire into this connector that wasn't there before from the old cable. But other than that, it's a plug-in place replacement for the board that used to be here, except that it runs the LED strings. So that's kind of going to be it for now. I do have another little thing I want to show you guys, and I'll probably tack it on the end of this, and that is we had some problems with our solenoid driver boards, and I had to fix them. And let me swing this over here so you can see that. Okay, so there's the solenoid driver board, and there was some problems with the board. And so I built a little tester that plugs into that. Let me move my pointer around. It plugs in right there, which is where the signals come from the microprocessor, and it allows you to test the whole board outside of the box. So it's really, really handy if anybody's into repairing these things. It's really neat, and it just takes one little microprocessor. So it's a Arduino Nano, as a matter of fact. And that's it. Some wires and some hooks, and it works perfectly. So I'll show you guys that later on. Okay, as I mentioned earlier, I want to show you this solenoid driver board tester that I built. So before we actually go take a look at that tester, I wanted to point out a few things in the schematic of the solenoid driver board, just so you have some idea of what we're doing. So to start off with, the solenoid driver board is divided into 4 functional sections, really. Down at the very bottom of the unit is the high voltage power supply. We don't use this anymore, since that was only used to drive the old style display units, and we've replaced those with LED displays, so that is no longer used in our machines. The next thing is a 5-volt regulator. It takes 12 volts in from the transformer and makes 5 volts, and it feeds that 5 volts out to everything that needs 5 volts, which is primarily the MPU, the soundboard, pretty much everything that needs 5 volts for computer logic type stuff is driven off of this single 5-volt supply. You will notice that right here on pin 13 on J3, there's a external jumper that runs up and provides 5 volts back into the processor on, I think that's pin 1 of J3. I really can't see it in the schematic, but I'm pretty sure that it's pin 1. There's been a mod on some boards that tie these two together so that you're not reliant on that jumper. So that's 2 of the functional units on this board. The third functional unit is this big section over here on the left, and these are the momentary solenoids. And the reason they're referenced as momentary solenoids is you can only energize any one of these 16 solenoids at a time. You can't activate all of them. Actually, I think there's only 15. I don't think they used the last one. So I think there's 15 solenoids here that you can activate. And over here on J4, pins 3, 4, 5, 6, and 7, data is input that selects which one of these particular outputs you want to turn on. And then there's pin 7 of that is a strobe that strobes the other 4 bits in to pick one of those 15 particular units to turn on. And then over here on the top right section, there are 4 continuous solenoids. So all four of these could be turned on simultaneously, and they could be held on for the whole game if they wanted to. As a matter of fact, the coin lockout solenoid is typically turned on as soon as you power up the machine, and it allows you to put coins in, and when the machine is powered off, that solenoid releases and it keeps you from putting coins in. So that solenoid is indeed activated for the entire time. Another solenoid that is activated is the flipper disable button. So whenever you put a coin in, you start to play, it activates the solenoid, which enables the flippers. As soon as the game's over, that releases the solenoid releases and the flippers can no longer be used. So those two solenoids are on at least for the whole game, and the other two could be other things where they may need a solenoid for something. So those are the four sections of this board. Now, the tester I built will test all 15 of these transistors that are driving solenoids and all four of these. It will not test the 5 volts. It will not test the high voltage. It ignores these two sections. Let me take you now and show you what this tester looks like installed on a board. Here is the Solenoid Driver board tester built out of a simple Arduino Nano and a 12-pin female connector, a couple of jumper wires, and a test probe. And this is a little spring action test probe that lets me clip stuff on. So as you can see, we have a USB cable coming up here providing power. And of course this is critical because you need to use the computer to select which transistor you want to test. And so obviously you need a USB cable all the time. And so that also provides power. Now the power that this board produces is relayed over to the board. The tester is plugged into J4 and the power is jumpered over to J3, and it's the bottom two pins of J3, pin 25 and pin 24. Now pin 24 and pin 23 are actually the solenoid ground, and then 22 up through about 20 or 18 or something like that are regular ground. And there was a mod a while back that bridged those two grounds together. So you just have to make sure that that has been done on the board, or this test won't work. The way the actual testing works is the board here is commanded by the computer to select one of the chips through the pins that are connected to this connector, and it selects that chip, which causes the transistor that it's relaying to turn on, and that pulls the collector of that transistor to ground. And so by using this probe and an LED, which is just connected to 5 volts on the side of the board here, and then a resistor to here, there's no active ports driving this light or anything. This is simply this board. So if I touch this to ground anywhere, that light will light up. And that is the test. So you have to watch to see if the chip is good or not. Now, one interesting thing about the pins, the first pin on this connector, pin 1 on this connector, goes to ground. Pin 2 goes to D2. Pin 3 goes to D3, all the way up to D12, going to pin 12. So it makes it really easy to program this thing because the port to pin alignment is the same. So it's really easy to understand what you're doing. If you want to raise pin 7 to strobe in a thing, you just strobe out to port 7. So you don't have to look them up or anything. So that's it. That's all there is to this tester. I will say that if you leave this sitting on the board for a while, the board does get warm. I think the The regulator is running about at its max current providing capability, but it is adequate to test this board, and I've run it for dozens of hours now without any failures, so hopefully it won't cause any failures. So these transistors are the ones that drive the solenoids themselves, and all they do, if I had the schematic up, I would show you again, but they connect the solenoid to ground. So the other side of the solenoid has 5 volts or has 40 volts on it, and when this transistor turns on, it connects the active side to ground, and that turns it on. So each of these transistors goes to one or more of the pins on this card, but the output is also available conveniently right on this tab. So it's easier to check them on the tab. The odds are that if it's good here, it will be good on the pins. You can check the pins, and my test routine tells you which pins to use, but you don't have to generally, because unless you've had a leaky battery that got over this, and normally the solenoid driver board is out of the way of the batteries and they don't get affected by that stuff, so you seldom have a bad trace unless something shorted out and burnt the trace out, and you ought to be able to see that. But anyway, you can test it if you want to. Now, I wrote a piece of software that generates the test pattern so that you can just step down each of these transistors and check it out. And it can test either the Bally or the Stern boards. Now, the Stern board, the transistors are ordered in a different order, so I had to make a modification to my code to test that out to make it easy and quick. But what I'm going to do now is shrink this image down and bring up the test program so I can show that to you. Board shrunk down a little bit. Behind it is the test code that is loaded on this little microprocessor right now, and you're going to be watching for this LED to turn on and off down here in the corner. I have the clip clipped onto Q1. Yep, it's Q1. And the test program is displaying over here in the serial monitor. You have to have the serial monitor to run this thing, so you know, it needs a computer or laptop or something handy with a serial monitor so that you can get the prompts and tell it what to do. So what it's saying here right now is I should press enter to test. I should hit a 0 through I if I want to go to a particular input, and that's basically it. So what I'm going to do is I'm going to hit enter right now, and you should see this LED blink 5 times if this bit of circuit is good. Okay, so it blinked 5 times, and then it automatically jumped to the next LED in this string. So my test is ordered to test these in order so you don't have to go looking around for them. So Q2 is right there. It tells you that you want to test Q2. We're also other parts of the circuit, and I'll bring back up the schematic in a little bit and show this to you. CR2 is a diode that is located right up here above this. So if you want to clip on the diode to test that, you can. And also, this is the chip that does the selection of the 16 different inputs. And then this feeds these 3 chips, and these chips are actually just 7 transistors in a chip. So it's selecting one of the transistors in the chip. And so on my test routine here, I say that this signal is coming from U1, inputting on 3 and outputting on 2. So if I wanted to go to U1, which is right here, I could test this on that pin also, and I'll show you that in a little bit. By the way, this connector I made up, I have either a clip or just a straight piece of probe wire that I can stick in there if I want to go probing around on things. But for right now, let me just hit enter to test this one. And as you can see, the light is blinking, so that one's good, and I can go on to the next one. Now, instead of testing it here, this next one says that this is on J2-5. Well, J2 is here, pin 5 is here. So if you want to test it on the pins, if you want to take the time to find the pins, you can. And that tests okay. And so now we're up to testing Q4. Q4 is right there. And you hit it, and it tests Q4. And you can just keep on, if you want to quickly test a board, you can just step on down the line and test it. If the light comes on immediately when you clip it on the transistor, then something is shorted out and or one of the other chips are causing it to turn on. So you'd need to troubleshoot that. It should always be in the off state until you activate it, and then it should come on. So I'll speed through this. But with this little tester, you can check a board out in about 2 minutes. And did I do something wrong? Okay, that last one I tested was Q14. Q14. Let me go back to that. So I'm going to hit a D to back up to D. And I'm going to go back to Q14. Hit enter. I didn't test. Q15. Let's step on down. Q15. Q16. Q17. Q18. Q19. But it looks like I might have a bad Q14. Interesting, because it didn't used to be bad. Q14D. I'm going to step back, hit a D to go back to Q14. No signaling. Okay. Just hit a D again to go back there. Okay, so this signal should be coming out of U3, 13, and 14. So let me put my other little probe thing on. U3 is right there. This is a 16 pin chip. So this is 16, 15, 14. Is that what I said? U3 pin 13 and 14. Okay, so that output is blinking. So okay, so it's coming out of the transistor on here. And it should be going to CR14, I believe. CR14. So let's go to there. And that's the input. So CR14, let me go to the other side of it. Okay, so that's the actual input to the transistor. Let me flip my test probes back around. And that should be going to J511. 15, 14, 13, 12, 11. Let me just test it here. So it looks like we have a bad chip. So Q14 on here is bad. It is certainly not working right now, and everything else is. So I found a bad chip. Let me bring the schematic back up just so I can show you what we've been testing. So give me just a second. Okay, you can see I've got the schematic back up, and over here are the pins that select which one you're going to do. This 4-line to 16-line decoder chip, this internal number tells you the binary code that's being put out, and this on the outside, the number on the outside is the pin it comes out of on that big chip. So right here, CR14, let me zoom in on that. Go back just a little bit more. Okay, so you can see that a code of 9, which is 1001, is coming in, and it's going in to U3 pins 13 and 14. So that's where I use my probe to probe these inputs to see if this transistor was toggling, and indeed it was. And then I checked on CR14 on both sides of it to see if that signal was toggling going into there, and indeed it was. And then I checked it on the output here, and also on J5 pin 11, and it wasn't toggling on either of those places. That tells me that Q14 here is bad. It should be coming on and off just like all the other ones were doing, and it's not. So that's how you use this little tester. This was a perfect example. And I didn't think I had a bad board, but apparently I do have a bad board. So that's really good to know. So let me very quickly take you through my code that is running this thing, and I think it's still up back here behind this. So let me widen this out and just zoom in on this a little bit, and hopefully you guys can read all of that. So at the very beginning of this thing, I have an array that lists the order of the transistors on the board. So the Q1 is actually index 1, and Q2 is index 0, and so on and so forth. So this just orders it so that I can just step down the transistors one after the other, testing them. And then I have a couple of arrays of strings that just tell me which pins a particular index number is on. Now these are in index order. So the very first one is 0, the next one's 1, the next one's 2, the next one's 3, and so forth. And then I have some more diag information about which Q, which CR. I could actually put all that stuff together now, but anyway, I kept it in two separate arrays. And then I just select a whole bunch of pins for outputs. These are all the pins on that connector that I'm connected up to. And the first thing I do is I run through and I set them all high, which basically turns them off. Once I get into the loop of the program, I print out my little instructions that tell you what to do. And then I set up a loop that loops through the 19 possible Solenoid Driver ICs on the board. And it outputs the appropriate string that's in the array saying, I'm at this point, and then it sits there and waits for an input from you. So once there's an input that has come in, I only use the first character of an input and I throw the rest away if you do any more. So if you just hit a return, I just get one character, the return. If you hit a 5 return, I will take the 5 and then I'll just flush the return. I don't need it. And then I'll make some decisions about whether or not you entered a number between 0 and 1 or a letter between A and I. And if you did, I will use that to jump to that particular point. And I do that just in my loop here. I'm looping by the variable I. Let me get back up to the top. I do a for I while I is less than 19. So all I do in this routine is if you input a number, I just reset I to 1 less than the number so that at the end of the loop when it increments it, it goes to that number. So if you want it to go to 0 and you type a 0, I would be equal to -1. At the end of this loop it gets incremented, gets to 0, and it'll redisplay the 0 value. And then if you haven't input anything and you've only, and it's an enter that we've gotten in, then you set the 4 bits that select the number. Remember I said that the one that wasn't working was a 1001, so that would be a 1001 in here. And then remember I said that pin 7 was the strobe, and so you strobe pin 7. There's a little routine right down at the bottom that does the strobe, and that's the end of the loop. And in this strobe thing, I just 5 times I set whatever pin you're telling me to strobe. In this case, pin 7. You set it low to activate it. You set it high to deactivate it. You wait a little bit. You repeat that 5 times, and you're done with the loop. And that's it. So it's a very, very, very simple little program, but it's quite effective. It makes troubleshooting these boards really easy. Okay, I have a Stern board installed now, and I have a little bit of different test code set up. My plan is to get this test code working for both Bally and Stern. Right now the Bally code has a little bit of a bug in it, but the Stern code is working. So you can see over here, the commands are almost the same. It says press enter to test a solenoid, press 0 through I to select a solenoid, and hit an X to toggle the mode. So if I hit an X here, it will put it into Stern mode. And you can see that the first transistor is Q7, where on the Bally, the first transistor was Q1. And as a matter of fact, if you look at the board down here, Q1 is all the way down here, and then Q2 is there, Q3 is there, 4, 5, 6, 7. So Stern laid out their transistors differently in this row, the pin outs on the pins are identical. So they just did that so they could wire the board easier and make it cleaner and neater, I guess. But it's a little bit confusing when you're troubleshooting. So anyway, so right now, 0 is selected. And if I hit an enter, it'll flash the light. And then again, if I just step through here, these should all be in order. And there you go. All of those are good. Now, I want you to notice something. I'm going to get my other camera here and get another little side shot of that. But if you look right here, you will see something that doesn't look quite normal. These chips with the 7 transistors in them, I forget what the number is. Let me see if I can read it on here real quick. ULN 2881, I believe is what that says. Anyway, you can't get them anymore. Well, you can get them once in a while. You can find them, you know, eBay and stuff like that. They're $5-6 a chip, and you don't really know what the state of those are. So Mike and I decided that we would just go ahead and build our own. So we had some boards manufactured up by JLC PCB, picked and placed, and this little chip here is a result of that. Okay, here you can see the little board that we have built. There are 7 tiny surface mount transistors on this board, and they're pinned out exactly like the other chips that we replaced. One thing of interest, on this particular board, these chips are mounted upside down. So pin 1 is in this corner right here. And you can see there's a little circle there marking pin 1. I can tell you from experience, if you plug these in upside down, it won't damage them. They won't work, of course, but it won't damage them. So that's a good thing to know. So anyway, we had probably about 100 and something of these chips manufactured from JLC PCB, and this was the first one. We simply soldered a couple of headers onto it and plugged it into the socket on this board. And the first time we tested it, it worked fine. So that's it. It's a wonderful replacement, and it cost us you know, less than $1 to manufacture, so way better than the $5 or $6 plus shipping from eBay. I don't know how the colors are going to show up on video, but here is a little demonstration of what the lights look like in attract mode, and we personally believe the table is just looking awesome. So anyway, we're getting really close. There's a few things we have to wrap up yet on this before it's a fully playable game. And one of the biggest things, and I'm just going to zoom on in here to the rollovers. I don't know if you can see it right there, but there's no rollover in that rollover. There's no rollovers in any of the rollovers, because when this table was constructed, they filled all the rollover holes with clear coat, and we have been having a terrible time trying to get those cleaned out. So we're actually looking at trying to come up with some non-moving rollover detector. We'll give more of that later if we get it working. But so there's no lights under those right now, and there are no switches under those right now. So that's one of the biggest things we have left to finish up to make this a playable table.